Good afternoon, ma'am.
Good afternoon. You're alone?
Yeah, yes, ma'am.
And then Anjay won't be joining today, but then this just one should be there, right? Okay, let it no issue. Am I audible?
Yeah, yes, ma'am.
So we are going to see about the valence bond theory because yesterday I have explained about the BSCP. You got disconnected or what in between? Because I couldn't see you later.
No, ma'am, I was there in class.
Yeah, last 5 minutes you were not there.
Yeah, I think last minute, yeah. I was disconnected, ma'am, due to network issue.
Okay, fine. So we are going to see about the valence bond theory. Yesterday I have explained about the BSCPR. Okay. VSEPR means valence bonds. Here it's given that you know you were not there, so I have to revise it. Valence shell electron pair repulsion theory. This is VSEPR theory. So this theory has been put forth by Sedgwick and Powell. These two scientists explained this theory in 1940. Okay. It is proposed a simple theory based on the repulsive character of electron pairs because if there are the two electron pairs, they may repel each other, right? In the valence shell of atom. And it was further studied and updated by the Nylund and the Gillies in 1957. So main postulates of these theories are there. In that first one is the exact shape of molecule depends upon number of electron pairs that can be bonded or that can be non-bonded around the central atom. Okay. For example, if we see the oxygen, hydrogen, and hydrogen, this is your water molecule, correct? So it's an
Yes, ma'am.
angular shape. It has a shape what? Angular. And there will be a certain angle in between, like 109 degree or 107 degree. Sorry, not 9 degree, 107-degree angle would be here. And its shape is angular due to presence of lone pair on the head of oxygen, correct? So these are the bonded electrons. And this oxygen has a lone pair on it. They are non-bonded, non-bonding electron. Same thing is for the shape of ammonia. If you see ammonia, it has a formula NH3. So central atom would be nitrogen. It has a 3 hydrogen, right? And one
Yes,
lone
ma'am.
pair on the head. Because of that, instead of triangular, its shape would be pyramidal. Okay. So the shape would be completely depending upon the number of electron pairs present around the central atom. That number of electron pairs can be bonded or can be non-bonded. Non-bonded means what? Non-bonded means what?
The lone pair.
Lone pair. Fine. Then the next one, the electron pairs have a tendency to repel each other since they exist around the central atom and the electron clouds are negatively charged. Means these electron pairs both are, means like how many it would be, they are negatively charged, right? So because of the like charges, they repel each other around the central atom. And they try to repel each other in such a way that they should not have any sort of hindrance around it. Okay, or influence of another negative charge on it. Repulsive character they completely minimize. And the electron clouds charge is nothing but negative. After that, electron pairs try to take such a position which can minimize the repulsion between them. And just now we have seen, right?
Yes,
Nitrogen
ma'am.
in this way, bonded will go at the certain angle from each other, and even the lone pair is also goes at the certain angle from the hydrogen, right? They would be the certain height, a certain structure, and they repel each other totally to make it completely repulsion free. Then the multiple bond is treated as if it is a single electron pair and the electron pair which constitute the bond as a single pair. So multiple bond also you have to take it as a single bond while confirming the structure in the VSEPR theory. Okay.
Hmm.
Triple bonds also you have to treat as a if it is single electron pair or electron pairs which constitute the bond as a single pair. Clear? That's
Yes, ma'am.
multiple that you need to keep it in your mind. After that, what is a valence bond theory and how you have to implement it? So in that, see, valence bond theory was introduced by Hitler and London in 1927. Is developed by the Pauling and others. It is based on the concept of atomic orbitals and the electronic configuration of atoms. It is based on what? Atomic
Atomic
orbital,
orbitals.
yeah, and the electronic configuration of atoms. Electronic configuration of atoms. Fine. Let us consider the formation of hydrogen molecule based on the valence bond theory. They have said. The hydrogen molecule, there would be two atoms of hydrogen. Suppose this would be Ha and this would be H. Correct?
Yes, ma'am.
Valence bond theory. So A and B having a nuclei Na and Np. Correct? And the electron present inside the hydrogen would be Ea and Eb. Okay?
Okay, ma'am.
As these two atoms comes closer, new attractive and repulsive forces begin to operate. Repulsive forces arise between the electrons of two atoms and nuclei of two atoms. Correct? Why? Because nucleus are positively charged, right? And
Yes,
electrons
ma'am.
are negatively.
Negatively charged.
There would be repulsive charges in between nuclei and there would be repulsive charges in between electrons. Fine. Attractive forces tend to bring the new atom closer, whereas repulsive forces tend to push them apart. Correct? Yes or no?
Yes, ma'am.
Attractive forces means like this nucleus and the electron must be having attractive force. In between nuclei and nuclei, there would be repulsive forces. In between electron, there would be repulsive forces. Attractive
But
force,
between both of them, there will be a attraction force.
yes, attractive forces try to bind them together and repulsive forces push them apart. So this situation arises while forming the hydrogen molecule.
Hydrogen molecule.
Yeah. Now orbital overlap concept, what it is that we have to see. Here it is. Now, according to the orbital overlap concept, covalent bond formed between atoms result into the overlap of orbitals belonging to the atom having opposite spin of electron. What they said? Having opposite spin of electron. Understanding? See, according to the orbital overlap concept, covalent bond formed between the atoms resulting overlap of orbitals belonging to the atoms having opposite spin of electron. Formation of hydrogen molecule
I
as a
didn't get it, ma'am.
I'll let you know. Wait a minute. Listen to me carefully first. Formation of hydrogen molecule as a result of overlap of two atomic orbitals of hydrogen atom as shown into the figure as follows. Opposite spin means what? Direction of this electron matters.
Okay.
This is a hydrogen, right? It has an orbital 1s. This is also a hydrogen, it has an orbital 1s. But then these two orbitals can be overlapped when the electron present inside it have a what? Opposite spin.
So if
Its direction would be,
one
yeah,
has
one should,
moving in a clockwise, other should move in anti-clockwise.
yes, yes. So one would be donated with the upward arrow, another would be denoted by the downward arrow. You can see the H2 molecule after
Right. Yes,
overlapping.
ma'am.
It consists the what we can say electron pair in such a way. One has an upward face and another one has a downward head. Clear? And this is called as the SS
Yes,
overlapping. So this is what? Opposite spin. What is this?
opposite spin.
Opposite spin. Right? Then only this overlap is possible. Now, stability of a molecule orbital depends upon extent of overlap of an atomic orbital. If there will be the really very proper overlap is happening, then the covalent bond will be stable and strong. If overlap is very less, overlapping section would be less, then that bond one that strengthful, and even that is weak bond. Okay.
Okay.
Uh, Even the multiple bond almost will not be formed by the covalent bond. There would be the pi bond. So covalent bond is more stronger as compared to pi bond. How it is and why it is, that too we have to see. Okay. Now we are going to see the type of orbital overlap. Which type of orbital would be formed, or orbital overlap would be formed in case of VS theory or valence bond, VBT, valence bond theory. Okay. So what is given? See, depending upon the type of overlapping, covalent bonds are of two types. That covalent bonds are sigma bond and pi bond. Just now I have told you. On the basis of overlapping, bonds are of how many types? Two types. First
Two
one would be
types.
sigma, another would be what? Pi bond.
Right.
Right? About sigma bond, what they said? Sigma bond is formed by the end-to-end, head-on overlap of bonding orbitals along the internuclear axis. The axial overlap involving these orbitals is in three types. Understanding? Which sort of bond would be formed sigma bond? When there would be the orbital overlap is end to end head on. Okay. An overlap of bonding orbital along the internuclear axis. The axial overlap involve these orbitals of three types. Okay. First one is SS overlapping. You can see here would be the axis. These are what? Your Cartesian axis, isn't it?
Yes, sir.
Yeah. So when axial overlap is happen, when see this is horizontal, this is horizontal. Horizontal overlap is happen over here. Yes orbital, yes orbital. Axial overlap. This is SS overlapping. Then the next one is
Yes.
what? SP overlapping. Another
S
overlapping.
orbital and p orbital.
Yeah, yes orbital and p orbital can be interact with each other to form a SP overlap. You can see. This is a diagram which can show you the sp orbital. This is s orbital, right? This would be a p orbital. This is also
Ma'am,
x.
there are like, why are there like different shapes for each orbital?
The Cartesian axis, isn't it? So these are also
Okay.
axial overlap, and hence it is sp overlap. Clear?
Yes, ma'am.
PP overlap, you can check here as well. These are also Cartesian axis. This is also axial overlap, and hence it is PP
Ma'am,
overlap. Yeah.
ma'am, if it is a SP and S overlap, so S will be on either sides, S orbitals.
Mhm. Yes.
If
Because p orbital is with the lobe shape. Okay, shape of the p
yes,
orbital
ma'am.
is in this manner. Okay, spindle shape it would be. And if we see the s orbital, it's a sphere shape. Keep it in your mind. These are the
Yes,
shapes.
ma'am.
Okay, clear? And these
Yes, ma'am.
orbitals and their shapes you might have learned in your earlier grade 11. No, no, no. You are in grade 10th. Na? You were in grade 10th.
Yeah,
Right?
yes,
I'm
ma'am.
teaching 12th grade only. Fine. So these are the shapes of orbital. S orbitals are round shape and p orbital are spindle shape in this manner. Okay. And when there will be the axial overlap, that overlap is strong enough, and hence sigma bond is strong as compared to pi bond. Now, what is a pi bond and how does it form, that we have to see. So these are what all axial overlap, right? These all overlaps are what? Axial overlap. And hence sigma bond is formed due to SS overlap, then SP overlap, and
And
PP.
PP overlap.
Clear? Yes?
Yes, ma'am.
Fine. Now we will move down. We have to see about the pi bond, what it is exactly. Yeah. Now you can check here with the pi bond. So see about pi bond, what has been given to you. Pi bond is formed by the atomic orbital when they overlap in such a way that their axes remain parallel to each other. Okay. And perpendicular to the internuclear axis. Sorry. And perpendicular to the internuclear axis, the orbital form is due to lateral overlapping or sidewise overlapping. Now, mostly keep it in your mind that pi bond does not form in s orbital. Okay, what you have to keep it in your mind, pi bond does not form into s orbital. It always form into p orbital or d orbital. Now, p
Yes, ma'am.
orbitals are spindle shaped, we know. Okay, so these are your p orbitals. These are the axis. Axis remain parallel to each other. They won't be. So this is the axis. This is also axis. This is also axis parallel to each other. Right? Yes or no? This is
Yes,
also
ma'am.
this. This is also axis and it is also axis. They are also parallel to each other. In this, overlapping is happened laterally in this way. Okay. Overlapping is happened laterally, no
Laterally.
overlapping. This kind of overlapping is what? Lateral overlapping. Okay. And as here lateral overlapping is formed, this lateral overlapping is not strong enough. It's not strong enough. It is weak as compared to your axial overlapping. And hence pi bond is weak as compared to sigma bond. Clear? Understanding? You can see this axial,
Strength of sigma bond will be more than that of pi bond.
sorry,
Strength of sigma bond will be more than that of pi bond.
sigma bond and pi bond. I'm not getting you. What you asked me? Can you repeat it
No,
once?
ma'am. Like the strength of sigma bond should be more than the
Yes, yes,
pi
yes.
bond.
Always, not should be. It is always more as compared to pi bond.
Oh, okay.
Is in
Yes,
the
ma'am.
sigma bond, overlapping is happened by axial overlapping, right? And pi bond is formed by lateral overlapping. If you rotate axial bond, there won't be any sort of change in the bond. It will remain as it is. But then if you change the orientation in the lateral overlapping, bond would be easily break. That's
Yes.
what I'm going to explain. Wait. Just now we are going to see. Understanding pi bond is formed due to what? Lateral overlapping.
And ma'am, pi bond can only be for P and D
Yes.
orbital, right,
Yes,
ma'am?
orbital does not form pi bond. Okay.
Okay, ma'am. Yes, ma'am.
Now see here. Means strength of sigma bond and pi bond is given to you. So sigma, this is a pi bond. A PF they have said, but then it's not the PF, it's pi bond. Okay. Yeah. Pi bond. Now sigma bond is formed by the axial overlapping and atomic orbital, while the pi bond is formed by the sidewise overlapping. Since axial overlapping is greater as compared to sidewise, thus sigma bond is said to be stronger bond as compared to the pi bond. Right? Now for the example they have given us this example. You can check it. See, these are the molecules formed by the sigma bond. Okay, A and B. Able to see? If you rotate it about 60-degree axis, there won't be no change. Another sigma bond A and B, p orbital axial overlapping is shown, right? If you rotate it by 60 degree, there won't be any change. But then if pi bond is there by the lateral overlapping, if you rotate any of the orbital by 60-degree, your bond breaks. And hence pi bond is weak as compared to sigma bond. Which symbol you're going to use? Sigma bond, and this will be pi bond. Okay, in this way you
Yes,
have
ma'am.
symbols. Clear? Now next is hybridization. What you're going to see?
Hybridization.
As I told you, I think earlier classes in my first or second classes, if you have listened my recording, I have explained you that hybridization we have to learn. But then I don't want to confuse right now. Definitely in future when you
Oh,
are,
right, ma'am. Yes, ma'am. Hybridization is there.
yeah, this term already I have explained, but then not in detail. Now see what is a hybridization. So now, in our regular basis hybrid food we have seen, it is a mixture of our some foreign variety and the Indian variety to increase the yield, isn't it? Yeah, crops,
Yes, ma'am.
then the fruits, etc. So that those fruits and the grains we called it as a hybrid, right? Yes or no? To increase the production of food.
Yes, ma'am.
Yeah. Now that hybridization is quite different, and the hybridization which we are going to talk about the chemistry, that is completely different. But then somewhat it is similar, means there is also mixing of something is happened, and here also we are going to mix the orbital with each other. But we're going to mix with each other hybridization. In hybridization, we are going to mix the orbitals, okay, of,
Yes, ma'am.
of a atom, different atoms, fine, in a molecule. Now, what is a hybridization? So definition is given to you. See what it is exactly. Hybridization is the process of intermixing of the orbitals of slightly different energies so as to redistribute their energies, resulting in the formation of new set of orbital of equivalent energies and shape. Clear? What does it
Yes,
mean?
ma'am.
In hybridization, what process we do? We intermix the orbital, which have slightly different energies. Okay. After intermixing, we redistribute their energies and we result into the formation, and it will result into the formation of new set of orbitals, which has a equivalent energies and shape. Means
So
after
the
hybrid,
different energies, slightly different energies, will be equivalent after
yes, yes.
hybridization.
So those orbitals who are different in their energies, in their shapes, after
They all will
hybridization,
become equal.
all of them will get the same energy and same shape. Clear?
Yes, ma'am.
Now, what are the silent features of hybridization? The first one is they have given orbital with among equal energy take part in the hybridization. Means the orbital must have near about same energy to undergo hybridization process. Second, the number of hybrid orbital produced is equal to number of atomic orbital mix. How many orbitals are mixed? That many orbitals only would be produced after completion of process. Right. Geometry of the covalent molecule can be indicated by type of hybridization. So geometry of the molecule is completely depend upon what type of
Type
hybridization
of hybridization.
happened. Yeah. And the hybrid orbitals are more effective in the forming stable bond than that of the pure atomic orbital. Hybrid orbitals are more effective in forming stable bonds than the pure atomic orbitals. Clear?
Yes, ma'am.
So what are the conditions are essential to undergo hybridization to the orbitals? In that, first one, orbitals of valence shell take part into the hybridization. All orbitals will take part into the hybridization of what? No. Only orbitals of valence
Balance shell.
will take part into hybridization. Second, orbitals involved in a hybridization should have almost equal energy. Just now we have learned earlier, right? I think second
Yeah,
portion.
slightly different only it should
Yes.
be.
And the promotion of electron is not necessary condition prior to hybridization. That means before hybridization, promotion of electron is not necessary. Means promotion of electron should be happen in each and every hybridization. It is not essential.
What is
Sometime it will
promotion of the electron?
understand. You will understand that. I'll explain.
Okay, okay.
Okay. Promotion of electron means what? If yes orbital is here, p orbitals are here, right? Only two p orbitals filled with the electrons. So one electron from the s would be jumped to the p, and you will get equal number of electron in all the orbital 1, 2, 3, and this is sp.
Right, ma'am.
This is sp3 hybridization. Okay. In this, what happened? The electron from s orbital is being promoted to the p orbital, right? So it is not a essential
Understood, ma'am.
condition. Clear? It's not an essential condition has been said. Clear? And every time it will happen, it's not necessary. And in some cases, filled orbital of valence shell also take part in hybridization. It's only unfilled electron, only unfilled orbitals will not take part into the into the hybridization. Sorry, filled orbitals also can be take part into hybridization. Clear?
Yes, ma'am.
I'm sorry. Now there are the different types of hybridization. Among that, first one we are going to see, that is sp hybridization. Okay.
Yes, ma'am.
Sp hybridization means what? When one s orbital and one p orbital hybridize to form two equivalent orbitals. The orbital is known as sp hybrid orbital, and the type of hybridization is sp hybridization. Now, sp hybridization means in that 50% s character is present, 50% p character is present. And this type of hybridization is also known as diagonal hybridization. What does it call?
Diagonal hybridization.
Okay, clear? The first type
Yes,
of
ma'am.
hybridization is sp hybridization. In that, one s orbital and one p orbital would be
Hybridized.
hybridized with each other. That is
Yes,
what? Which consists what? 50% of s character, 50% of p
ma'am.
character.
Correct.
Clear? Such a hybridization is called as sp hybridization, and it is also known as diagonal hybridization. Correct? And this is the
Yes, ma'am.
sp orbital. This is what? sp orbital. Clear? Yeah. After hybridization, shape of the sp orbital will be in this way. Because S has a sphere shape, P has a spindle shape. When these two would be mixed with each other, it will result into this way. This is your S character, this is your P character, and another means like would be there, no, what P character that wouldn't be take part into the sp hybridization, so it minimized and hence it would be removed completely. Okay, and hence it become what? Diagonal hybridization. Clear? Yes. Hello. Tracy.
Yes, ma'am.
Now see next. sp2 hybridization. In this type, one s and two p orbital hybridize to form three equivalent sp2 hybridized orbital. Understanding? How many
Yes,
orbitals
ma'am.
part in this? S and 2p.
And
So
2p.
there are three. So it will be generate three sp2 hybridized orbital.
Right.
Okay, understanding how many orbitals are taking part, that many hybridized orbitals would be generated. 1s, 2p means total 3. So 3 sp2 hybridized orbital you will get in this case. Clear?
Yes.
Fine. Now see the next one. In this, all three hybrid orbitals remain in the same plane. See what is said. All three hybrid orbitals remain in the same plane, making an angle 120. Means if you get a sp2 hybridization, so each and every bond has an angle in between what? 120.
120 degree.
Yes, 120. And diagonal means this angle would be what, beta? 180 degree. Clear?
180 degree.
A few compounds in which sp2 hybridize takes place are BF3, BH3, BCl3. Carbon compounds containing double bond. There also sp3 hybridization would be taking place. sp2, I'm sorry, not sp3, sp2 hybridization. Okay. So Cartesian
Yes,
action
ma'am.
in this manner, S plus Py plus Pz. When these orbitals would overlap with each other, it will result into these molecules. Are you able to see? Wait a minute, let me
Yeah,
just.
yes, ma'am. P orbital is also represented by two circles, right, ma'am, in that other one picture.
See, one, suppose these are the S and two P orbitals would be mixed with each other, and it will be result into sp2, sp2, and sp2 orbital, and bond angle between is 120. These are sp2 hybrid, correct? And all these are sigma bonds. And blue,
Yes, ma'am.
clear? The formation of sp2 hybrid and in a BCl molecule, BCl3 molecule. How sp2 hybrids are forming BCl molecule is been shown here in this. Okay. And the structure is what? Planar. Planar, and what we can say it would be trigonal planar, right? Triangular planar structure. sp2 hybridized. Now see the next, sp3 hybridization means what? In this type, 1s and 3p orbitals in the valence shell of an atom get hybridized to form 4 equivalent hybrid orbitals. Okay, there are 25% of S character and 75% of P character in each sp3 hybrid orbital. And the 4 sp3 hybrid orbital are directed towards 4 corners of tetrahedrons. It will goes at 4 corners of tetrahedron, and hence the shape of sp3 hybrid orbital would be tetrahedral shape. Okay, so this is your first lobe, this is your second lobe, this is your third lobe, and this is your fourth lobe. And if you join it, you will get the shape tetrahedral. Got it?
Understood, ma'am. Yes.
These are the axes that you need to join data. Clear? So your
Yes.
methane molecule has a tetrahedral shape, and tetrahedral shape has a bond angle in between what? 109 degree, 0.5.
Okay.
Very important, okay? The angle between sp3 hybrid orbital is 109.5 degree. And a compound in which sp3 hybridization occurs is a methane, CH4. Then the structures of NH2 and H2O molecule can also be explained with the help of sp3 hybridization. But due to presence of lone pair, their shape would be slightly different. It won't be tetrahedral. Okay? Because angle get changed. Understanding? Yes? Hello? Tracy?
Yes, ma'am.
Now the next one would be what? Formation of molecular orbitals or molecular orbital forms that we have to see. Shall I explain it now or shall we continue it tomorrow? Because it's 4:30. I think you have to join for the other class as well.
Ma'am, my physics class is not there today, though.
Other class is not there.
Yeah.
Fine. But then you're alone with me. So I think I need to repeat it again. The other students. Then I
Oh,
just attending today's class. So text me regarding linear combination, LCA or principles. I have to explain. It's easy. About to finish, don't worry. I'll finish it soon. Tomorrow, the day after tomorrow, our chapter will be finished. Okay?
okay, ma'am.
I think I have to end the classes. Learn for the hybridization. If you have a text, learn for the hybridization. We'll see what is to be done. Clear?
Yes, ma'am. Thank you,
Second,
ma'am. Bye, ma'am.
welcome. And I'm sorry I have started the class little late today.
No worries, ma'am. Yes, ma'am.
Thank you.